Hey there. This video is going to go over how to solve absolute value inequalities. So our last one was on absolute value equations. Similar to that, but it's going to be a little bit different because inequalities indicate that we are going to have a range of solutions, not just one or two solutions. Like if here's an absolute value equation, if the absolute value of x is equal to c, then x could either be c or negative c. Whatever c is, when you take its absolute value, you get a positive result. So if I put c in here, the absolute value of that would be c. And oops, if it's a negative c inside here, when I take the absolute value, it becomes positive. So with inequalities, we're going to have a region of solutions rather than just a specific point value. So for example, if the absolute value of x is less than 3, what we want to do is we're looking for all the values of x that are less than 3 units from the origin. So here's my origin. 1 is less than 3 units, so is 2. So are all the points in between here. So it's this whole region from 0 to 3, but less than means not including, and there's no bar underneath that. Let me erase that, because now it looks like we do have a bar. So we're going to have an open dot, because open is not included. An open circle is like it's representing where the point would be, but it's not filled in, which means it's not really there. So this is not included. And hello, Mr. Hemstop.
Hello.
This, if it's filled in, means it is included.
Oh, star belly sneeches and the non-star bellies. I get it.
Okay, so where was I? All the points from 0 that are less than 3 units away from 0 would include all of these points along here until you get to 3, but not including 3. But also in the negative direction, because we're talking about distance. So you can use that open circle, which means it's not included, or if you use the interval notation, then it would look like this. You would have parentheses because it's not included, and you really don't, when you use the parentheses, you don't need to shade because it's indicating that it's between those two parentheses. So the next problem here, how about if x is greater than 3 units? Well, then that means we're talking about all the values of x that are more than 3 units away from the origin, which is from, like, 4 is more than 3 units away, but so is 3.1 and 3.01 and 3.0001. So we use that round parenthesis here, and it's all the values of x that are farther away than 3 units from the origin, so this way, and then also -3 on down. And let's write this solution here in interval notation just to review that. So I'm going to use parentheses, and this is for the one up here where it's x is less than 3 units away. The absolute value is less than 3 units away. I'm going to go from -3 to 3, not including the endpoints. And now these are x values. Remember, domain is x, and so we're talking about a region of values, not an ordered pair, because it kind of looks like an ordered pair when you have just parentheses. For this graph down here, for interval notation, this keeps going forever in the negative direction. So all the x values from -infinity up to -3, and then get rid of that page number, and then and then we're going to do a union, because it could be any value over here or any value over here from +3, not including 3, to infinity. So that's the solution written in interval notation. Oops, I forgot to end that one. All right, so this is an extra step. We want to first isolate the absolute value piece, and so I'm going to add 4 and add 4, and I'm going to go down here. Absolute value of x is greater than or equal to, the 4 is crossed out, greater than or equal to 11. So now I'm going to put this into the cases so that it looks familiar, like what we were doing with the equations. So if I have case 1 and case 2, I'm just going to graph it first, and then I'm going to show you how that relates to the two cases. If it's going to be greater than or equal to 11 units from the origin, that would be over here at 11, going this way, because it's greater than 11 units away, or equal to, so that's why I'm using the square bracket. And then also over here. So if we look at like how to write this inequality, like let's start with this one over here. That it means that x is greater than or equal to 11, which looks just like this solution without the absolute value bars. And then just like when we solve equations, we got to do the negative part, the negative 11. But what has to happen is we have to flip the direction of the sign when we do the negative, because this solution, the solutions over here are values of x that are less than or equal to negative 11. Here's negative 11, this is negative 12, which is less than negative 11, and so on all the way down to negative infinity. All right, how about this one? If the absolute value of x is greater than or equal to negative 8, when is the absolute value of x greater than or equal to negative 8? Well, it always is greater than or equal to negative 8, so all values of x would work for this. Give me a value of x, like if I put 3 in here, 3 is greater, the absolute value of 3 is greater than or equal to negative 8, or negative 3, which equals 3, is greater than or equal to negative 8. You can't get a negative, so everything, it's all positive. The lowest it could be would be 0. So all values of x would work for this. In interval notation, that means it'd be from negative infinity to positive infinity, and it would be the entire number line. Okay, so here's how you're gonna want to approach these. First thing you want to do is isolate the absolute value, which this is. The absolute value of x minus 5 is on one side by itself. So let's break it into the two cases, case 1 and case 2. Got to remember, anytime you see that absolute value, you're going to want to remember that there's two cases, possibly. And so the first one is we're just going to write x minus 5, what's inside the absolute value, is less than 3, just like this is written out, except for without the absolute value bars. And the second case, let me do this with a different color, is going to be x minus 5, and then remember I said we're going to switch the direction of the inequality sign when we do the negative case. And then we solve both of those. So I'm going to add 5, I'm going to add 5, and I get x is less than 8. That's one piece of the solution. And then add 5 over here, add 5 to negative 3, and we get x is greater than positive 2. And that is the other part of the solution. So if we put this on a number line, I need 8 and I need 2 to show up on my number line, so I'm going to put like 0 over here, 1, 2, 3. I guess I don't need to read these out loud. Okay, so x is, this is saying x is less than 8. So if x is less than 8, that means it's going to be to the left of 8. And the green says x is greater than 2. So it's going to be to the right of 2. So the solutions would be anything within that region. So let's pick a number just to test it, like 4. If I put 4 in for x, the absolute value of 4 minus 5, is that less than 3? Well, 4 minus 5 is negative 1, and the absolute value of negative 1 is 1, which is indeed less than 3. You can pick any number in that region, and it'll be a solution. If I pick any number outside the region, it will not be a solution. For example, 0. If I put 0 in here, the absolute value of 0 is, this is negative 5. The absolute value of negative 5 is 5, which is not less than 3. So that's a way to check your work. If you pick values inside and outside, inside of the region, it should be a solution. Outside, it should make it false. Okay. Next example, why don't you try to do it on your own? Break it into the two cases, remembering to switch the inequality symbol when you do the negative, and then check your work. So if you're doing this on paper, make your number line so that it makes sense. I made a number line that's going from negative 2 to 2, and I broke each in 1 unit increment into 4 parts, because my solutions are x is greater than or equal to 3/4, and the other part is x is less than or equal to -1/4. Since they're both in fourths, to make this easier for me to graph, I thought that would work really well if I did go by fourths. So greater than or equal to 3/4, I'm going to do this one right here. 3/4, this is 1/4, 2/4, 3/4, and so I'm going to make a square bracket facing to the right, because the numbers that are greater than 3/4 are the ones to the right. And then the other solution over here was x is less than or equal to -1/4, which is right here. And less than or equal to means it's going to be a square bracket again, and numbers that are to the left of that. So that would be your solution. So if you didn't get that, let me just go through this. So we set this up, case 1, we set it up as 4x minus 1 is greater than or equal to 2. Case 2, we do 4x minus 1 is less than or equal to -2. In both cases, you're going to add 1 to both sides, and for case 1, I get 4x is greater than or equal to 3, and it's 4x, so I got to divide by 4, so 3 divided by 4 is 3/4. You don't do anything with that inequality sign, but remember, if you do have to multiply or divide by a negative, you do want to switch the direction. And then the other case over here, I added 1 to -2, and I get -1. Divided by 4, I get -1/4. So that's how we did that one. All right, so I'm going to do 4 more examples in the second video. These examples involve like an extra step, like example 5 that you see on the board right now. First thing you want to do is you're going to subtract 6 and then set up your 2 cases and solve. So I will do that in the next video. If you understand this and you're good to go, awesome. Otherwise, watch the next one.